So here we are illustrating the fact that any series of rigid transformations can be reproduced by at most 3 reflections. So I start with 2 figures here that I know are congruent. I know that the yellow figure is congruent to the blue figure because I produced the yellow figure by a series of rigid transformations of the blue figure. So my goal now is to show that I can reflect the blue figure onto the yellow figure using at most 3 reflections. Well, first we know that to map any point on the blue figure to the corresponding point on the yellow figure, I need to reflect across the perpendicular bisector of the segment that joins those 2 points. So first we'll construct the segment joining those 2 points. Next I want to construct the perpendicular bisector of that segment. So we start with a midpoint and we make a perpendicular line to the segment through the midpoint. So this will be my first reflection line. Okay, now that I have a reflection line, I'm going to select the interior of the blue polygon as well as the vertices of the blue polygon. And I'm going to reflect that over the reflection line. Okay, so here comes my first reflection. And that first reflection basically maps one vertex of the blue figure onto the corresponding vertex of the yellow figure. So I still have 2 reflections that I can play with. So again, I'll pick 2 corresponding vertices. So this time, and actually, why don't I hide the reflection line that I already used? Okay, so we'll do that. Okay, so this time I'm going to again pick 2 corresponding vertices. I'll pick this one and this one. That choice is arbitrary. And I'm going to do the same thing. Construct a segment between them, construct the midpoint of that segment, and then have a perpendicular at the midpoint. Okay, so this is my second reflection line. And again, I'm going to reflect the entire interior and all points on the vertices. Okay, so that was pretty successful because I can see now that I basically have a almost like a bilateral symmetry. So there is some line or axis of symmetry that I can put right through the middle of there, and it's going to reflect the blue perfectly onto the yellow. So in order to do that, I can again just pick 2 corresponding vertices. This time I'm going to go ahead and pick these 2 here. And again, I want to construct the segment that joins those vertices, the midpoint of that segment, and the perpendicular to that segment through the midpoint. Okay, so this is my final reflection line, or at least it better be because I only get 3 reflections. So again, here we are. We're going to transform or reflect the blue. And this time it's not so important to reflect the vertices. But here we go. Okay, so when I take this off, I expect to see some green. And there it is. I guess you can call that green. All right, and just to clean up the mess, we'll get rid of all the excess that we're not using right now. Okay, and then we'll see that all that's left. Okay, maybe I didn't do such a good job of cleaning up, but basically you can see that all that's left is the green region, which represents the overlap of the blue with the yellow, and we achieved that by doing exactly 3 reflections. And that's what the theorem says, is that it will never take any more than 3. So sometimes it might be only 2 that are required, but definitely never more than 3. And there we have it.